negative 5 halves plus I over 2 times x sub 3. X sub 2 is this scalar times x sub 3. So negative 1 half plus half of I times x sub 3. And x sub 3 is an independent variable that can take any value except 0 because we're looking for non-zero solutions. So factoring out this independent variable x sub 3, we have all the solutions can be written as a scalar multiple of this vector, negative 5 halves plus half of I, negative 1 half plus half of I, 1. So all the eigenvectors corresponding to the eigenvalue 1 plus I are 3 by 1 eigenvectors that can be written as this scalar multiple where x sub 3 is not 0. These are all the eigenvectors of lambda sub 2 equal to 1 plus I. So what we just found is for this eigenvalue 1 plus I, there is one eigenvector, negative 5 halves plus half of I, negative 1 half plus half of I, 1. So for the complex conjugate of this eigenvalue, 1 minus I, which is also an eigenvalue, without going through a similar procedure of calculating non-zero solutions of a linear system, we know that the complex conjugate of this eigenvector, which is negative 5 halves minus half of I, negative 1 half minus half of I, 1, is an eigenvector corresponding to 1 minus I. And since 1 minus I is an eigenvalue of algebraic multiplicity 1, we know the geometric multiplicity of this eigenvalue is also 1. So eigenvectors of lambda sub 3 equaling 1 minus I can be written as the set of vectors x that can be written as scalar multiples of this vector that are not 0.